It's on. So it's already past 11, so let's get started. My name is Anu Märkälä. I work as project manager at CSC IT Center for Science in Finland, and I'm one of the persons in EOSC Future who have been supporting the collaboration between EOSC Future and the EOSC 07 projects. And I'm happy to welcome you to this session of EOSC Exchange capabilities, co-organized by EOSC Future and the 07 projects. Today we will hear presentations from all of the projects on how they are enriching EOSC with new services and resources, and what are their benefits to communities. As you can see, the agenda is quite packed, so let's take all questions at the end of the session. So without further ado, I will give the floor to Jan Meijer, who will give an introduction to what EOSC Exchange is.
Or what it potentially could be. Yeah, thank you. So I've been asked to give kind of like a call it technology neutral introduction of what the exchange is, what we can view it as. My name is Jan Meijer. I'm the co-chair of the EOSC Association's Task Force for Financial Sustainability. Am I making music? Where is that coming? Ah. Okay. The objective of the task force is to, by next year, have a proposal for the long term, as in 2027 and beyond, financial sustainability of the main EOSC building blocks, the core, the exchange, and the federation of data. We're a group of nearly 30 people, and we've now been going at this for a year. Our interim report has just been released. So, if we are to come up with a proposal for financial sustainability of these three components, then basically you have to figure out, well, okay, so what is it that you're talking about, right? What is this exchange that needs to be financed? How it can be financed, right? What is the thing that needs to be financed? And then you can answer how and how much it's going to cost. So what is the exchange? Well, from what I can tell, and we've been asking a lot of different people and looking at a lot of different definitions and projects, it depends. Depends whom you ask, depends on the vantage point. If you're a research infrastructure, it's something different than if you're an e-infrastructure, which is again different if you're a pan-European infrastructure, is again different if you're the researcher that's supposed to use all this stuff. So it depends. Well, that makes it a bit difficult. So what we all seem to agree on is the exchange is a marketplace for services, right? What does that mean? A technical platform that facilitates federated services. There's this concept of horizontal thematic services. Cross-border service use is a thing that always bubbles up in those discussions. Access to commercial services is part of it. That's where I spend quite a bit of my time. Is the exchange business to consumer? Is it business to business? Opinions seem to vary, and investments have been made in both directions. Right, so what is it? Well, marketplace of research services. But these questions haven't really been properly answered yet by us as a collective. It's all floating around. So at the moment, there is no real good answer to what is the exchange, but you can make a couple of assumptions. And for whom is it, right? So if you model this very simply, EOSC consists of a federation of research data, marketplace for services, and then there are various delivery channels to get all that stuff out to the researchers through the RIs, through national service providers, through e-infra providers. There's a whole bunch of service providers out there. There's a gating process in order to get into this EOSC, and then ultimately that stuff is being delivered to 1 million researchers, thousands of institutions in about 40 countries. I keep forgetting how many countries are in Horizon Europe, but it's about 40. So that's the model that we're working from, very simplified. And after many discussions, where we are at the moment is that you can slice that chunk of exchange into basically 3 essential components that seem to make sense. So this service provider space out there seems to, if we want to enable all different service producers to basically share their services with others, right? A university produces an interesting services and want to share it with someone else, or that happens on a country level. You need someone who facilitates the brokering of those services, because that is actually really hard, because then you have to start answering questions like contracts, money flow, VAT, and lots of other nasty questions. So it would be great if the EOSC marketplace facilitates that type of thing. And then obviously there needs to be a number of remuneration methods for that, because that's also really hard. This could be pay for use, it could be other mechanisms, it could be tokens, it doesn't really matter. Concept is there. Out of all the possible services, you can then carve out two different other components. You can argue that, well, of all the available services, there's a certain number of them that as a community we deem very useful for the whole community, right? That would be the so-called horizontal services. There could be a bunch of services that would be really good to bridge the digital divide. There could be services that would be good to have there because we want to stimulate the uptake of novel services. And so there could be a number of reasons why you want to have services in a centrally financed pool. What is in that pool? How big should it be? Well, it could be anywhere from 0 to endless. So you need some mechanisms to figure out how to size that and to figure out what needs to be in there. Our current report says scientific advisory committee. Maybe you could also figure out a more algorithmic method that you say based on certain KPIs it would make sense to be in there. But key is that, well, you approach this as a collective rather than individually. And then last but not least, as part of the exchange, you can imagine that it would be really good if researchers in Europe have access to a certain portfolio of commercial services. And that's, I think, where I want to leave that at. So I'm looking forward to all the presentations that we're going to enjoy in this session to figure out more what is actually in the exchange. Thank you.
Thank you, Jan. I'm going to move on a little bit from the high level to the slightly lower level in what we've actually done in realizing the exchange within the EOSC Future project, and to tell you a little bit about its benefits and how it fits in with the other concepts, specifically the core. So this is the architecture diagram of EOSC that we started with at the beginning of the EOSC Future project. We can see the core at the bottom, and we can see the exchange at the top, composed of, as Jan said, horizontal services, services from clusters, from the infrastructures, and also from the different communities onboarded as well, and also potentially from SMEs, from the private sector, services, resources that are useful for open science and for the EOSC-directed communities. So here we have the marketplace as it stands, which is really the front end to the EOSC resource catalogue. The URL at the top is wrong. It should be search.eosportal.eu. My apologies for that. But this is the way that you can actually discover what those capabilities, those objects, those services and resources are. And there's a very impressive number of onboarded providers and resources from within the EOSC Future project, and also from the OpenAIRE research graph as well. They're all there ready to be searched, and I will correct that URL at the top of the page afterwards. We originally started with onboarding resources and services within the project, and now along with the OpenAIRE research graph, we have onboarded lots of different other concepts as well, so catalogues, data products, training material, software, EOSC interoperability guidelines, the list goes on. So it's a very dynamic list of resources here. So let's have a look then about how the exchange fits in with the core. I'm sure you've heard these words before. What do we mean by the core? Well, the EOSC core is essentially the glue that holds everything together, the thing that makes EOSC actually function. They are almost all intended for the service providers rather than the end users. So, for example, the monitoring, accounting, security coordination isn't directly serving the users. One exception, though, is the help desk. The help desk is very much used by the end users, and this is part of the core. Whereas the exchange then, the horizontal services, the thematic resources, the onboarded SME services, etc. And we can make use of these different services to compose them together. What do we mean by service composability? What we really mean is just by making use of these EOSC services and resources together in order to solve a problem. What we've done so far is bring together a very large number of resources. Our next step is really to make them easier to interoperate one another. So there is some degree of intelligence, knowing if you have some data set, which services, which workflows may be used against this data set to solve common problems. And that is something that we're working on very hard at the moment. We've also come across this term horizontal services. What do we mean by this? So Jan, you mentioned it as being essential services which are centrally financed. That is absolutely true. That is the case now. But we are now looking at the possibility of making the horizontal services actually expandable by adding new horizontal services in the future. And in order to do this, we've come up with a definition which we think is workable. It's a generic service or resource bringing significant value to multiple research infrastructures. Now, the devil here is, of course, within the detail. How do we define generic? How do we know its sufficient value, etc.? But at least this is something that we're starting with and that we're taking forward in order to implement before the end of the EOSC Future project. Okay, the final thing in this slide is I'd like to consider an example here. A user may want to run some specific workflow that could be available through the exchange to run a resource from a onboarded repository on an EGI federated virtual machine stored on EU.beta safe. So these are examples of exchange services, and these services may be discovered and ordered on the EOSC marketplace. Now we're using the core, accessed over the EOSC AAI to give them single sign-on, so the user does not have to log on separately to each resource, which is a big bonus for the user, with a help may be provided by the EOSC help desk. So this is a very generic example of how you can make use of both the core and the exchange in complementary capabilities. Thank you. Back to you, Jan, I think now, is it?
Okay. Right. So we've been working for quite a while on how to provide access to commercial services through EOSC. So this is where I take my long-term project hat on. So I think everyone more or less agrees that commercial digital services should be a standard part of the researcher's toolbox. Variety of services that you can imagine that would be useful for. Infrastructure cloud comes to mind, right? Your Amazon Azure, collaboration services, Earth observation data services, stuff that makes it easier to use Copernicus data, many different services. But how do you then do that? And what does access to commercial services actually mean? Because most of the EOSC users are in the public sector, you can't just go to the shop around the corner and just buy them. Right? You have to go through certain processes. So we've been doing this activity in a variety of different projects. Right? There's a straight line that goes from Helix Nebula Géant 4 through OCRA to EOSC Future, onward to Géant 5.1, where we've looked at essentially joint procurement of services, stimulating adoption of those services, and by doing that, developing an approach plus the processes that actually scale to the size of EOSC. And remember, that is the 1 million end users, it is the thousands of institutions, and it's the 40+ countries. In practice, we've tested this approach with infrastructure cloud and Earth observation services. That was mainly done in OCRA and EOSC Future. So you've seen this diagram before, right? EOSC Exchange with a gating process to get service providers in. And then the idea is that as part of the exchange, you would have a collection of commercial services. But how do you then do that? So The value proposition that we arrived at, how does this make sense for the researchers? Procurement compliant agreements with research relevant services. A couple of questions that arise from that. For an institution, that means that they can tell their researchers, look, if you need a commercial service and it's part of that EOSC portfolio, then you're good to go as long as you have the money to pay for it. Where does the money come from? Well, that's a different question. That could be the grant, it could be institutional money, that doesn't really matter. What matters is check the EOSC portfolio, you're good to go. These are good agreements with good conditions. We don't have to run a process for that. For the researcher, it also means that if they go to their research support, say, I need this service, research support gives them trouble, they can say, look, it's all good. It's in the EOSC portfolio, right? So if you scale this to thousands of institutions, that's going to prevent a lot of discussion and it's going to save a lot of time. Intermediary aggregators, again, they can offer less complexity access through them to those services by taking care of all the complications that arise with entering into contracts, making subscriptions available, etc., etc. And for EOSC as a whole, what we're basically saying is we're doing together, which is hard to do alone. What is hard to do alone? Getting Microsoft to actually give you useful concessions, like free data egress. Why is free data egress important? If you store 20 petabytes into the cloud, it would be really nice if you can afford getting it out again when you want to. Things like that. The other added value here is do once what otherwise needs to be done thousands of times, which is, for example, the procurement exercise. It's also things like the GDPR questions that you need to ask all these providers. So there's a bunch of things that everyone needs to do and that are basically all the same. And we can save a lot of time there. So that's the value proposition of that. And that all contributes to digital sovereignty. It can contribute because once you have started to do these things as a collective, you can use that collective to actually just slam with your fist on the table and say, well, if you can't get us a nicely digitally sovereign solution, then we're going to point all that aggregated demand to someone who can. And that's the game that you can start playing in the long run. And we think that that's interesting. So there's a bunch of practical things that you do need to address because this is not really trivial. EOSC is big, right? So which services do you procure? How do you assess demand and requirements in that big community? How do you do that at scale? We're experimenting with that. We haven't really figured it out yet. What type of procurement vehicle to use? Framework agreements are nice, but they lock the market for 4 years. There are more dynamic ways of doing that, which might fit better with other service areas, but they come with their own disadvantages. Joint procurement with EU countries is easy because the European Procurement Directive explicitly supports that. But with associated countries, it's more difficult because you don't necessarily have the legal basis to do it, as we found out. Next question is, right, once you have actually entered into these agreements, you know what you want to procure, how you want to procure it, you've done the exercise, then how do you get these contracts ultimately out to the researchers? Because it has to be done through a legal entity. And with thousands of institutions, this again is a non-trivial exercise. So in EOSC Future, we're now experimenting with using intermediaries as a channel for that, because that would scale a lot better. The jury is still out on that one. And then there is the whole financing aspect, because what we now know, because we've done it twice, is that if you do this for the infrastructure cloud area, it seems to cost roughly between about 1 million euros a year, if you amortize all the costs that you need to make over the whole system. That includes the demand aggregation, the central procurement, and maintaining those agreements over time. And circle of life, right? You can't just do this once. So if you have a framework agreement that spans 4 years, then after 2 years you have to set the next process in motion, because by the time that the old ones expire, well, about 3 months before that, you have to be able to roll over to the next ones. And there is a cost associated with that, and you need to carry that, and you need to have that money available and the people to do it. So what does this then boil down to? Well, in that previous picture, so you get a bunch of procurement compliant agreements with research relevant services in the EOSC Exchange, but with a different gating process. You can't just apply the rules of participation. You have that procurement as a gating process, but the rules of participation feed into that. And you need some strategic portfolio management, because the people executing the procurement obviously shouldn't be the people that pick and choose what stuff gets procured and what doesn't. At the moment, it's, well, the funding dictates. There could be more effective mechanisms. So the current portfolio of commercial services is basically what we achieved in OCRA, which is IaaS+, so Infrastructure Cloud Services. It's available in 40 countries, but effectively not really in associated countries, because legally speaking, it just doesn't work, as we learned. These agreements offer nicer R&E conditions, so no data egress. Your mileage may vary, but for a number of providers, this is certainly true. Nicely connected to the AI, if you want that. There are discounts, there is the consultancy of the suppliers, and more. CERN testing toolkit has been applied. We have about 25 platforms, so there's about 6 American hyperscalers, and the rest is European platforms. And these are available to thousands of legal entities in 40 countries, as in literally about 10,000 institutions, I think, were on the aggregated list. And for them, this is sign the contract and you're good to go. You don't have to do anything else. If I recall correctly, the June numbers were about total aggregate revenue that has flown through these agreements is about 125 million euros, and they are used at that time by about 800 institutions. My guess is that at the end of this year, we're looking at, well, it doubles about every year, the revenue, and I'm guessing the amount of institutions will be up to about 1,000. So we're starting to make inroads there. In EOSC Future, we have the opportunity to use adoption funding to stimulate the uptake. There is a call out now, which is about developing this channel for delivering these agreements to the users. We'd like to see if using aggregators works, right? They have established channels to the users use the services in context. If you plug in these commercial services in the back end, it makes it a lot easier to distribute them to those users. It takes the form of a mini competition, which means that if there's an aggregator interested in this, they need to team up with a supplier. The supplier delivers the proposal. There is a short deadline for this first call, 15th of December, but there will be another call with a certain amount of awarding criteria, and we're really looking at how valuable is that service distribution mechanism, how well can the plan be executed, and what is the sustainability plan for that. Next step, so we've delivered a tested concept at the end of EOSC Future, a practical approach with a couple of funding calls, and we're working to integrate that concept into what the EOSC Association's task force will deliver on sustainability for EOSC, right? And then we need to discuss the longer term operationalization of the concept, and that's a big question mark. Who's going to do this? Who can do this? So I'll leave it at that. Thank you.
So good morning. I guess it's fine. I am Haris Hadjikyriakou. I work at the Earth Observation Data Center in Austria. And today I'm going to talk to you about how C-Scale contributes to the EOSC Exchange capabilities. But I will start with a small introduction about our project. So I guess you all know Copernicus, the European Copernicus program by now. It is proven to be one of the major sources for high-resolution Earth observation data on a global scale, and it gives us huge loads of new data on a daily basis, so huge volumes of data. However, to this day, there is no integrated infrastructure for processing and hosting the data. So this is what we wanted to address with C-Scale. Therefore, to create a federated data and computing infrastructure, which we are planning to offer through the EOSC Portal. The project therefore stands for Copernicus EOSC Analytics Engine. It started in January 2021 and it will finish next June 2023. It's a relatively small project, so it is 2 million euros budget, and its consortium consists of 11 partners with a pan-European coverage, as you can see in this little map. Both from the EO world, including representatives from the ESA collaborative ground segments and from the diocese, but also from the EOSC world. So we have quite some partners that were existing EOSC providers, compute and data providers. So I would like to go through the services that we are planning to offer as Exchange capabilities very fast. And I would like to start with our main, our core, let's say, service, which is the one called Fed Earth Data. This is exactly the federation that I talked about, the federation of Earth observation data archives together with the computing capabilities for processing and analyzing Earth observation data. As you can see in this graph, if we start from the right side, a user can authenticate with EGI check-in and access our cloud resources, both directly using the cloud infrastructure as a service, but also in combination with Parse Orchestrator and Container Orchestrator. In addition, we also offer a batch and interactive processing environment, where batch see the OpenEO and where interactive see the Jupyter notebooks. If you look at it from the left side, someone can authenticate with SRAM, which is another AI system developed by one of our partners, and you can access HTC HPC resources. As you can see, our data federation is a layer that can be accessed from all sides, also independently from the user perspective. And this service relies on the core services from EOSC that are listed in the corner, so AAI, accounting, monitoring. You heard me talking about OpenEO, which is our batch processing system, environment, rather, but I wanted to talk about it a little bit more because we're planning to onboard it as a separate service in the EOSC Exchange, in the EOSC marketplace. So OpenEO platform is a parallel project funded by ESA, parallel in terms of runtime to C-Scale. And it wanted to address the problem that you see at the top left corner. So the different colors of the arrows that go from the backends to the different clients indicate the different languages that these backends used to have. To overcome this, the OpenEO API created a common language for backends towards clients. Therefore, you see the same color. That was that aimed to remove the complexity of setting up the IT infrastructure for the users before performing their workflows, and rather letting them focus on their science. The current running project, the one called OpenEO Platform, added an extra aggregation layer on top, which created a single entry point for the users. As you can see in this graphic, the backends are again hidden below this aggregation layer. And it supports 3 different clients, the Python client, the R, and JavaScript. It offers a web editor for users that prefer to work in an interactive environment, and of course, Jupyter notebooks. For the discovery of the Copernicus data in our data federation, we have developed the metadata query service. We never had the goal to create another metadata database. We rather want to create a query broker and integrator, and this is what this service is. It offers a single point for listing the datasets for all the data providers, and they have a shared protocol, which was chosen to be STAC, the Spatio-Temporal Asset Catalog. This is a relatively modern protocol that we see that's being used quite a lot in the science communities, and let's say that we wanted to follow the trend, to be compliant. Very quick, I wanted to show you on the right side the browser of the service, because I think it looks quite nice, quite intuitive. So if you follow this link that you can see under the image, you get a list of provider and data set, so all the data sets of every provider. You choose the one that you want, and then you get another page that shows you all the information around the data. You can see on the right side, you can see the spatial and the temporal resolution, the provider, the platform that produced the data, and then on the left side, you can find, okay, of course, the description of the data set and all the items that are included. Of course, there is also the command line version, but I don't like the black backgrounds in my screenshots. To ensure that the Federation is addressing the user needs, we started the project with 6 native, we call them use cases, from the environmental and climate change domain. We have been working very closely with them. We have established tools to enable the feedback loop. We have a forum and we have very often meetings with them. We collect their feedback and we try to address them in our future developments. As you can see here, we have listed, like, in very short, their topics. So, for example, the first one, Aqua Monitor, tracks the changes between land and water, floods and droughts. Water Watch quantifies water availability in reservoirs. High Sea provides information about weather and water for ports and aquaculture. The LSDA use case looks at the river discharge and forecasts it. Return is looking at the tropical forests, it's their recovery capacity, and wetland water stress analysis. Look at the wetlands and try to protect them as they serve as a methane sink when they are healthy. When they are not healthy, they rather emit methane. In addition to that, we opened also an open call. We started an open call in the first months of the project to onboard external use cases and further challenge the Federation. And we also offer our services through the EOSC EGI-ACE. You can see here some examples of use cases that have already been onboarded and the ones that are in progress. And this is our open call, where you can see if there is someone in your community that would be interested, would be happy to receive their application. From the use cases, we have the last service, the one called Workflow Solutions. So the use cases produced several workflows. These workflows are getting generalized so that they can easily be temporally and spatially upscaled. And our plan is to offer them also as a service in the marketplace for users. Therefore, to support and expand their usability of these workflows. They are mainly for the monitoring, modeling, and forecasting of the Earth system for now, but we keep on onboarding more and more use cases. So let's see what they're going to include in the future. And the closing sentence for me is that for now, our C-scale services are being used by our users by communicating, let's say, directly to C-scale. They're not in the marketplace yet, but it is one of our main plans for the near future. And of course, we are really focusing on the sustainability aspect of it since we are now in the last part of the project, and it's a big question. Thank you very much. That was it from my side. And I don't know who's next one. Dice. Yeah.
Okay, thank you. Good morning. So I'm Antti Pursula from CSC. I'm the head of secretariat for EUDAT infrastructure, and I'm also a work package leader for the service provisioning in the DICE project. So I'll tell you about the DICE contributions to the EOSC and EOSC Exchange. So this is a summary slide of the project. I'm going to more details on these topics later on, but it's a project funded from the Infra EOSC 07 call. We have 24 partners. duration, budget. The coordinator is Deborah Testi from Gineca. She was not able to be here, so I'm presenting now on behalf of her. The key target, key purpose of this project is to enable a European data management infrastructure for EOSC and for European research in general. And for this purpose, we provide generic services for data management and data storage. And there are 18 providers in the project offering a lot of capacity, but also other types of other advantages of the services. Our project is built very much on the basis of the EUDAT infrastructure. So EUDAT is a pan-European infrastructure for data management services. This is a picture of our consortium. Main part of the project members are really involved in this service provisioning activity, but we also have involved user community representatives and a couple of other partners. And also, I said, most of the providers are from EUDAT infrastructure and most of the services are EUDAT services, but we also do have other service providers and other services in the project. So, as I said, objective enabling this European storage and data management infrastructure. But we also have some other activities that are working on enriching the services to better support some, let's say, more advanced or emerging use cases like sensitive data or access or connection to long-term preservation, connection to compute infrastructures and supercomputing, so on. And in this picture, I try to show how DICE services fit into the context of, let's say, research process and research data lifecycle. On the left-hand side of this picture, you have kind of the data generation part. So there are instruments and also computing. On the right-hand side, there is again data processing, data analysis, reanalysis, and so on. And then on the top, discovery services, scholarly information, or some global search services. But what is there in between is where the data, it's basically the fair data management part. So where the data is stored, metadata is added, persistent identifiers is added, data is published, and so on. That's where our services come into the play. And there are a lot of connections between these services in this picture, so it means that the services are able to work together. They can be used as an interoperable set of services, and there are interfaces to services on the outside of our project, let's say. This is another type of view of what actually are the services that DICE project is providing. Now you should read this picture from the bottom to the top. So at the bottom are computing and all types of computing. Then you have different data type of services, and then data discovery on top. And between these blue lines is the realm of DICE project. Okay, I will click through these. Easier to explain this way. Yes, so we have categorized our service offering in the DICE project into these 5 categories. Personal workspaces or project workspaces, it's kind of a cloud storage for active data, and the corresponding service name is B2Drop. It's the EUDAT B2Drop service. Then there are data archives, meaning, let's say, simple storage. Not so active data, can be large data. Third category from the bottom is then policy-based data archive. It means that the preservation, bitwise preservation is enhanced with some value-added services like replicating the data or doing integrity checks and automation and so on. And then data repository for publishing data, adding the metadata. And for discovery, we count both those services that provide persistent identifiers or DOIs through DataSite, who are also a member of the consortium. But also importantly, our metadata catalog, B2Find, that harvests data from tens of repositories, not only from the EUDAT services, but also from several thematic and community repositories. So the services are horizontal, generic. I'm not sure if I use the horizontal services in the same sense that Matt was saying in the introduction, but I think it could be the same. So it really is independent of a scientific domain or the use case. Although the services are possible to customize, though, it's possible to add there some thematic extensions, like for the metadata or so. We do have significant amount of resources available through this project, more than 50 petabytes of storage if you count all the different types of services provided by all the providers in the project, the 18 different providers. And services can be used as a standalone service, so one at a time, or as a combination, or integrated to a community platform or computing. So they are quite versatile in that sense. Also in that sense, I would say. Okay, I wanted to show one quick example of a use case. Sorry, there is not much, or there is no scientific content on this slide, so it is only the schematic of how do we deal with the data. This is one of the communities that have also representative in our consortium, computational biomedicine. It's a European consortium that has established collaboration and are working together, I mean, already long before the DICE project. So there, how do we support them with our services is that they are first computing a lot of data using the HPC systems in Barcelona, BSC, and then SURF in the Netherlands. Then data from computing is stored in a close proximity of this computing, so using the B2Safe service. And the data is replicated between these two sites, later planned to replicate also to University College London, who are part of the project. Then we assign PIDs, persistent identifiers, with the B2Handle service, so that the data can be easily referenced and we know which data set is where and so on. And finally then data would be published in the B2Share repository and findable from B2Find. So this kind of shows one example where there is both connection to outside of the DICE project in the computing, in the beginning of this process, and then working with several of the DICE provided EUDAT services integrated to each other. Okay, before I conclude, some statistics of our activity. This is from the midterm report, so it's already about 6 months old. We have supported 85 user projects with the DICE resources, and they are taking use of several providers, services, and also the number of users is close to 2,000. And you can also look at the number of scientific domains, which is here 16, so showing that really is a generic service offering. We are not focusing on 1 or 2 science fields, but they are from all across the science landscape. Okay, finally, how can the user then find those services? First of all, they are available at any time, so we are not running any calls with deadlines and so on, but they are, as these are based on operational services that were there already before the project, so we are able to provide access at any time. And there are several ways of requesting access. One, a good one is to go to the EOSC marketplace and search for either with the service name or with EUDAT, but then you can also filter the results services so that you take those who are associated with DICE as a platform and then continue from there. Also, the users can go to the EUDAT website because we are utilizing the EUDAT order management and processes even for other than EUDAT services in this project. And there either go to the EUDAT service catalog and make the request or write the support request to us. And I should also remember to mention that we are also providing services for the EOSC Digital Innovation Hub program and the Early Adopters program. So the services are available for those users as well. So thank you. This was my part. Thank you for attention. So it's Giuseppe.
Okay, so good morning everyone. I'm Giuseppe La Rocca, I'm Community Support Team Leader at EGI Foundation, and I'm going to present how EGI-ACE is contributing to the EOSC Exchange. So the project is a 30 months of project, officially started the 1st of January 2021, and it's a flagship project for EGI because we have a lot of partners from the Federation that are contributing. We have more than 33 partners, and additional partners are third parties. We are delivering services to target different stakeholders. Of course, the primary stakeholder for us is the community, so research community, research infrastructure, also H2020 project. We are also supporting business identity, and of course we are offering a solution for maintaining our federation up and running. The scope of the project is on service delivery, which means that we have a limited effort dedicated for developing activities. So most of the budget from the Commission is dedicated to the operation of production and scalable services for EOSC. So this is the main target, the main scope of EGI-ACE. This slide summarizes the impact of EGI-ACE so far. So what has been done so far? We managed to integrate and contribute with the onboarding of different technical services and also thematic services. We are supporting domain-specific use case and data space provider. Most of them are now already available in the EOSC portal. So in principle, community interested can also browse and request access to these services. We are serving a lot of users, more than 70,000 of users. Most of them are from thematic services, but EGI-ACE is also opening a dedicated open call, because what we want to do is to increase the user base. So through this open call, we are able to identify additional communities that may be interested to deploy and run their thematic services or data space in our infrastructure. So this is just a summary slide of the impact of EGI-ACE on EOSC. So how, in a nutshell, the goal of the project is to contribute to deliver the compute platform for EOSC. How this is done is through this three-tier architecture. So we start from the bottom, which is the infrastructure layer. EGI has a long-running experience in federating capacity, computing and storage capacity. What we have done is to extend this resources capacity, including additional cloud resources, mostly from public, but also from research cloud, and now recently also with HPC. On top of this infrastructure layer, we have the platform services that basically provide the capabilities for helping the different communities to run data analytics, for example, with the big data using a web interface like a Jupyter Notebook, if you are familiar with this technology, or deploy virtual cluster pre-configured with some specific software on top of infrastructure as a service. We provide solution for training a module using machine learning and artificial intelligence, and also orchestrator to run jobs, submitting jobs on the federated resources. The platform services also provide the glue I don't know if, okay, it is working. So the glue to implement the interoperability between the federated compute, identity, and data management, which are three main area of innovation for EGI. So thanks to this interoperability area, we are able to offer the application layer that you see on top, the capability to run and deploy your cluster and scalable data analytics services on the EOSC, in EOSC. As I mentioned before, we are mainly targeting the Green Deal, health and humanity and medicine and fundamental science sector, but we are also opening to extend and open with additional use case via the open call. I mentioned before that several services have been already integrated. You see here the breakdown. So federated resources from the different cloud, HTC and HPC provider. We are offering compute and data federation services. So we are operating our proxies, checking proxy for providing access to the resources offered by operation of the infrastructure. We are also offering this functionality via Perun and the master portal. For the software distribution, we are relying on the application database, which basically is a catalog of a marketplace catalog of software where you can that can be deployed in our infrastructure, and also CVMFS. For the compute orchestration, we rely on the infrastructure manager and AC3, which are developed by UPV, and other solutions like a workload manager from CNRS and pass orchestrator. And we are also providing solution for having transparent access to data management, including data hubs, data transfer based on FTS, Rucho, and OpenRDM. For the platform services, as I mentioned before, we are operating EGI notebooks, which is based on a Jupyter Hub technology, solution for the machine learning and artificial intelligence, and also the ODAS for the distributed data analytics. Okay, these solutions are contributing to evolve the portfolio of use case and community we are supporting. This is a breakdown of the data space and thematic services supported by the project. 5 of them, the one that you can see here circled, are the ones, the data space that have been onboarded recently in EOSC, thanks to this collaboration. And we are also supporting other thematic services that you see here. So as I mentioned before, all of them are now in EOSC Portal. So they are operating production services for serving their community, and it can be easily discovered and accessible through the Portal marketplace. The technical support of community is an important aspect for us. So we are established this engagement pipeline, which involves a network of experts to provide the right technical effort, identify the best services that can support the integration plan of the different community. The entry point is, we have identified 2 different entry points for us. One is of course, the portal marketplace, where the user can submit a service order, and the second is the open call. For each of the community, for each of the requests that we receive, we perform an initial assessment of the technical requirement. If this assessment is successful, we allocate a supporter, an expert that will liaise with the customer, will liaise with the service and resource provider, and provide all the technical experts to support this integration plan. We allocate the resources also, and we also launch a competence center, which is a sort of mini project just to support the integration plan of the use case in the EOSC Exchange. So under this competence center, we start the co-design activity, we validate the result, and of course, if we are successful, everything is onboarded in EOSC. 2 important concepts of this network or engagement network is the concept of shepherd, which is the supporter, the expert of the federation that can provide the consultancy and has the knowledge to facilitate the integration plan. is also responsible to monitor the integration progress and also provide some solution in case of showstoppers. And this concept of competence center, which is the concept of the project under which we support this kind of activity. This is a network of team from different areas, so it involves not only experts from the federation, but also from the community, and under this network, everything is supported, so the community is supported. Okay, these are the total of use case we selected with Open Call. You see here the breakdown for disciplines. So the Open Call was officially launched in April 2021. We did a marketing campaign to promote this Open Call and reach as much as possible new projects and communities. We received so far 42 different use cases. 38 out of them has been officially supported by the project using national fundings and budget coming from the project. And we are also supporting the business use case through the EOSC Digital Innovation Hub. This is the status of this activity. Sorry, I'm finishing. So this is the status of the business use case, and of course we are interested to talk with other sister projects from EOSC 07, because we would like to evolve the services offering and provide the new functionality to evolve these the services that are available in our portfolio. So for each of the 07 project that you see here, we started this activity to, for example, for DICE, we have integrated B2 drops in EGI notebooks, and B2 share is already a source of input for data transfer, and integration with the B2 Save is already in place. Similar activity with OpenAIRE. We have already complied with Zenodo. EGI binder is able to recognize the DOI and use this information to generate replicate the signs. We have already our information from EGI application database is already harvested. With Reliance, we are offering the infrastructure, in particular the notebooks and EGI data hub as a data store. And for C-Scale, we are offering the authentication solution, so check-in and Perun, and other solution like the pass orchestrator and the notebooks for interactive computing. And this is my last slide. Sorry, I was a bit late. Thank you.
Can I get out and reload?
Yes.
I did it.
It's the same folder, so
yes.
Go back there.
I'm reloading already. Okay, it should be fine.
Here. Do you want to
okay,
share
no,
from
but
here?
okay, that's fine. I can also reuse the ones that are here.
Yeah.
Can you see them?
You are there.
On top. Okay. Yep, these are the right ones. Okay. Good morning, right? Yeah, we didn't have lunch. Okay. So, Nexus. I'll try to be as quick and concise as possible. It's an infra EOSC 07, so it started in January 2021 and will end in 2023. This is the budget we were kindly allocated. The coordinator is OpenAIRE AMKE, and then a number of beneficiaries are there, some of them coming from the OpenAIRE family because we're operating OpenAIRE services. But we also included in the portfolio new services very useful to the community, so we included new partners in the roadmap, namely University of Bologna, which is behind Open Citations, which we really wanted to have as part of our family, call it, of Open Science Services. CNRS, who's running EpiSciences, that is very useful. And, well, yes, and then of course GRNet, because we wanted to have the AAI very nicely combined with the EOSC one. So This is the picture that represents all the OpenAIRE services as they are today, the portfolio, which we have organized in 3 main pillars: publish, monitor, and discover. Publishing services, as you can see at the top, we are targeting many kinds of users. Publishing are typically used by publishing services by researchers, citizen scientists, and also SMEs who are publishing their own content, their own data, and all this stuff. AP Science, the services in red are the ones that were not yet as part of the family and have been included as new ones. So publishing APIs, APScience.org is a service that is run by CNRS and offers the tools to define overlay journals. So you, as a group of editors or researchers, can define your open access overlay journals, taking advantage of the network of repositories out there. So the principle is that authors who are already publishing preprints in Zenodo, in HAL, in this case, these are the 2 main integrated repositories, can fetch their submission straight from the original repository. So it's a way to re-exploit the infrastructure as is and to place open access publications through a proper peer review and through journal publishing. Zenodo, we all know what it is. I'm not going to delve into this. Amnesia is a service that provides pseudo-K anonymization of data, of sensitive data. It's integrated with several data formats from different communities. It's not an online service for obvious reasons, although you can find an online version to play with to start seeing how it works, but it's a tool that you can download on your desktop to anonymize your data and eventually at the end of the trip publishing it straight into Zenodo through the tool itself or wherever you want using your own platform. Argos is a data management plan. So this is the kind of tool that you want to use when you're planning an activity, especially in European projects. And you need to define your own DMP. It's a tool that offers machine accessible DMPs, in the sense that everything you do there is tracked and structured. It connects to other services in the scholarly communication, ORCID, ROAR, many services that are actually providing ways to structure your offer in terms of DMP. Also in the future to assess it, properly define statistics, for example, how many projects are relying on Pangea as a repository of reference. These are the kind of calculations you can define. It's for free, so you can register with your EOSC account or ORCID account and define with a group of colleagues work together in the definition, creation, and progress of a data management plan. Then we have the monitoring tool. Monitoring tools, we really care about them because we believe they are key for the community as a whole. They are key because they finally take all the open data out there and bring it into a context where anybody can reuse it. So assessment, trends, monitoring should be in the hands of the community, not of enterprises. I'm not sure Elsevier is sitting here, but this is one of the issues we're having today, paying millions for that. The Commission is pushing a lot towards open access in general, but more in general in the ways scientists should publish their data, making the offer as open as possible, also in terms of the metadata they're providing. Okay, so monitoring is a set of tools that are extremely important in the community to make this possible, to achieve the objective. We have open citations, and we all know what it is. It's an incredibly important service that is now running, and fortunately others are joining in. Crossref has recently shared a set of citations kindly, so we can find them in there, and you can access links between articles and articles in there. Scholar Explorer is the service that we have provided in OpenAIRE, which is the one that provides the whole collection of links between articles and data and software, okay, which we're trying to collect from all possible repositories out there, including DataCite, doing mining as much as possible in the data we have, and so on. So the two together are actually giving us an incredibly important view over science and how it evolves. OpenAPC is tracking APCs, which for those who are not in the field are article processing charges. So we are tracking at the level of DOI how much an institution, a specific one, has spent in euros, so we can calculate, estimate the cost of this hybrid scenario that we have today between open access, closed access, and paid open access. Usage counts is a service that tracks downloads and views at the level of PIDs in general. So when a repository joins the usage counts architecture, it pushes all the events about downloads and views about the PIDs that it contains. We aggregate them, therefore, across different sources, and we provide the totals, which are available for anybody to use, develop new indicators, new discovery techniques, and so on. The Open Science Observatory, as well as the OpenAIRE Monitor, are together the ways that we exploit this data and offer it to the world. So, as you will see later on in another slide, Monitor offers on-demand gateways that enable the calculation of statistics about a specific community behavior, or research infrastructure, or organization, or funder. So you can access to the trends of open science in your research infrastructure, or the trends of gold publishing among your researchers, as well as many other statistics, open science related, usage of ORCID identifiers, something like that. Of course, this exploits the graph that is below, and it is actually powering all this, because we are collecting all the data inside and making it available to the world. Discover acts a bit like monitoring. It's a way to view the content of the graph and discover its content and navigate its content from the point of view of different communities. And here again, as a community, you can come and get your gateway. So monitor and explore, connect gateways are the kind of horizontal resources that we are offering to the community. We have actually provided more than 40 since the beginning of the project. So an important target is, of course, to integrate with EOSC. So all our services are integrated in the EOSC core services. At the level of the EOSC AI, with some details yet to be defined, but we were also there in the front line testing the accounting for services, accounting for resource products, and monitoring. So we are fully integrated as much as we could. What are we providing to the core? Well, many services in our family were used and reused to empower some of the functions and capabilities of the EOSC core. A key one is the provide. The OpenAIRE Provide is a service that we are offering to service providers to come register a data source, a repository, an archive, test and validate its metadata records with respect to the guidelines that we have defined with the community, the OpenAIRE guidelans, so-called OpenAIRE guidelines, defined via working groups which are still active. You're always welcome to join, and which now have been inherited and adopted in the EOSC. So through this tool, you can evaluate, validate your repository, get feedback. So there's a report that you get back telling you where you fail, which are the fields that are not properly used, and so on. And so you can, let's say, calibrate your export. And once you're fine, you can become part of the graph. So we collect your data, we schedule a workflow for you that works over time and collects the data and brings it into the graph. So Provide became the gateway for the research products in the EOSC. The graph is a part of what we call today the EOSC resource catalog, because the other side is the EOSC service catalog, which is now being integrated, and as such plays an important role in this domain, in this scope, let's say. The accounting for research products exploits what we call usage counts, and it collects the data from different data sources, joining again the architecture, downloads and events, and this time it integrates them into the EOSC resource catalog, so it's fully integrated with it. So if you access the data in the EOSC resource catalog, you're able today to find the downloads and views attached to every single PID, which are being refreshed at every indexing round. And then on top of that, we exploited the explore function as the on-demand function to provide access to the whole graph, to provide the in-context search to the EOSC marketplace, which instead refers to the subset of resources that have been onboarded. This roughly summarizes. So these are some numbers. I'm not going to really delve into this, but all these services have reached their KPIs. Some of them actually too soon, but that's also because the budget that we were assigned was not much. So we had to justify that, but everything is going according to the plan, and you can check the numbers later on maybe. So we have 25 new journals in EpiScience. I invite you to check the service and offer it to your colleagues and services. Monitor and Connect are the ones that we are pushing a lot because we believe they are the open access and free way to have access to the data. And we have more than 40 dashboards today available. So please contact us for further details. This is the last slide, just to tell you that the graph is today being used not only by the research domain and the commission, of course, because it's funding it, but also by many companies worldwide. And this is actually a matter of pride for us because it means that it's useful, it's actually running innovation and powering innovation and business, which is one of the key things, making science available also for that kind of activity. And that's it. So, thank you.
Thanks. You're 60 something. There.
Thank you. So hello everyone, my name is Raul Palma. I am from Poznan Supercomputing and Networking Center in Poland. I am coordinating the Reliance project, which is the last one of the EOSC 07 projects. I will try to be very brief because we are running out of time. So let me just start with a brief introduction of Reliance. So we are contributing to the EOSC Exchange with a set of research enabling services that allows the open, efficient, and cross-disciplinary management of the research life cycle in order to support the adoption of fair and open science principle. So Reliance services basically aim to enhance the discovery and access to research data, of course, including Earth observation data. We are also targeting, scalable data access to Copernicus, for example. But also we are extracting relevant knowledge from scientific text and other scientific resources related to investigations, and to manage the research life cycle as a first-class entity. So this is one of the key things that, let's say, highlight in the project, the management of the research life cycle as a key and first-class entity. Our services are being demonstrated in several communities, especially from earth science, but most of our services can be applied in other domains as well. So we are 9 partners in Reliance from different places in Europe, and we can see here on the right-hand side the main 3 services that we are bringing. That is the research objects and management platform, which is called ROHAB. Then we have the advanced geospatial data management platform, which is ADAM. This is the data cube management platform. And then we have a bunch of text mining services that allow this enrichment, recommendation, and other kind of nice function that I will show you in a minute. So, as research object is one of the backbone technologies behind Reliance, it's important just to give you a bit of context of what is it and why is the reasoning of using research objects. Basically, they are rich information objects which aim to account, describe, and share everything about your research, including, of course, how things are related to each other. So imagine that you have, you are working in your research, and normally you have a lot of different resources that are put and placed in different locations, different repositories, which, of course, they are related, but they are not accessible from a single point of access. And this is what the research object provides. It provides an integrated view over fragmented resources, of course, using PIDs and metadata. But most importantly, of course, is that the research object itself, it has its own metadata as well. So it can be managed, it can be evolved, and it's in its own right can be packaged and deposited and shared. So that's the concept of research object behind. So the ROHAB platform is the holistic solution for the management of research objects. This is the main service that we are bringing into the EOSC Exchange for that. So this, of course, includes the storage, lifecycle management and preservation of research objects, sharing and making available these resources to others, publishing these resources with DOIs as well. So it's important that the research object itself can be considered as a live entity, because when you are working on your research, you are continually adding, creating resources, using data, producing data, and so on. So for all of these resources, we are using W3 identifiers, which are also PIDs, but when you are making some kind of snapshots, we can also associate DOIs as well from data side, because we are also a data side provider. So many features, of course, regarding the tracking the research object impact, assessing the quality of the research object, not only in terms of the fairness, which is a service that has been just recently released. We are trying to aggregate all the different elements, fairness, and provide like an overview of the fairness of the research. So this is what we are bringing now. It's just in the process of being integrated, but also we are bringing services for assessing the quality in terms of the community needs. And this is based on something that we call the checklist services. Of course, you can do some collaboration, monitor the activity of the research object, so you can get notifications when something changes. You can also, of course, reuse the research object and make a fork to start your own research. Of course, this will bring the acknowledgement to the original work as well. And most importantly as well is that you can enrich, the platform enriches the metadata of the research object based on these text mining services that I will show you in a minute. So that's the main service regarding the research objects. Then we have Adam platform, which is the platform for the management of data cubes. So it has a 4-layer architecture. On the bottom, we have, of course, the infrastructure layer, which is a federated network of infrastructure providers, which are providing the data layer, of course, the data sources that are provided by those infrastructure providers. And then there is the data cube layer. So this data cube layer is the one that is put on top of the data sources, providing a standardized interface to access to the original data sources, which can stay at their own source. And on top of that, of course, you have the presentation layer, which includes different types of interfaces. That includes a GUI, of course, very nice interface where you can visualize the data on the globe, and the 3D. But also you have, of course, access via a specific instance of a Jupyter Notebooks. You have also APIs and CLI tools as well in order to access the data. Then regarding the text mining services, so there are 3 main services. The first one is the enrichment one, which extracts semantic metadata from the research object content. So you can see on the top here how it's the process. So basically you have the research object, then this service extracts all the resources aggregated in the research object, but also the description, general description, the title, and that kind of descriptive metadata about the research object. Of course, it's starting to do some kind of filtering, and then generate the semantic annotation via, of course, some kind of AI technologies here, and extract things like topics, for example, what are the main topics related to this research, what are the key element, phrases, concepts, lemmas, sentences, and entities that he identified in the text. So, for example, people, locations, time references, that kind of things. And then this is enriching automatically this research object. So this metadata, you can see it as well as part of the research object. So based on that information, we have the search interface, that is a keyword and faceted search of research object, and the recommendation interface that allows you to do this, we call it the collaboration spheres, where you can put at the center your research object, and then you will see, related research object or related people that is identified based on this semantic information that has been extracted. And now, very recently also, we have been releasing new experimental services that are just really moving forward in terms of the boundaries on what can be achieved in text mining. So basically, in order to identify claims in the research that are described in your text, in your resources, questions and answers, and also challenges and solutions. So this is, thing that we are identifying now. This is experimental, but, it's a very, very nice kind of feature that we are going to bring as well very soon into production. Finally, so here you see the connections between Reliance service and the EOSC core and EOSC Exchange. So all our services are in the marketplace, but the most important here is how we are connecting to the different elements that are available already. So we, of course, are using the AAI from EOS Core. We are connecting to OpenAIRE Research Graph that was just presented before. We are using Argos, for example, to create research objects based on data management plans. We are using Bit2Drop to provide the personal storage for the research object. We are using Zenodo and Bit2Share to release research object snapshots, but also we use notebooks and Binder from EGI to get access to the computational environment directly from RoHub, and of course all these other services that I mentioned from Reliance. Finally, in terms of the use cases here, we have a reference multidisciplinary use case, which is basically trying to identify the impacts on the coastal environments that was caused by the lockdown during the 2020 lockdown. So there is a lot of very interesting information that they're analyzing from many different perspectives. And this is a very nice showcase of how multidisciplinary can be done in support, with, of course, from the EOSC and Reliance tools. Then we have several vertical use cases that are dealing with sea pollution, loss of biodiversity, extreme weather events and climate, and reducing the consequences of large volcanic eruptions. Apart from that, of course, we are getting some new things coming to the project based on, for example, the DIH from EOSC, which are at least 4 projects have been expressed interest in using our services. We are getting on that. We have also an open call, and we got already some tree cluster also from different communities in earth science. And even European projects as well from Horizon are using our services as well. Finally, I just encourage you to go here to this adopters page, where you will see a lot of training materials, videos, user manuals, and so on, for you can start using our services. So thank you very much.
Thank you, Raul. And with that, we've come to the end of the 5 overviews of the EOSC 07 funded projects. Many of these capabilities are already involved and onboarded onto the EOSC Exchange. Some of them still plan to be and will be before the end of their projects. Now, we had planned to do a panel discussion, but sadly we do not have enough time for that, but we probably have enough time for 1 or 2 burning questions for the speakers. So are there any questions?
So I have a question, but it's rather a general panel-style question, and it is for everyone. You've all talked about your links to non-European entities at some point. How important do you feel that is for the development of the exchange? I know it's the European Open Science Cloud, but how do you see that developing in the future?
Anyone like to take that question?
Well, the associated countries are an integral part of the whole European exercise, right? So Norway is not part of the EU, but is definitely a European country, as is this whole ring in the southeast. So it would be really bad if they wouldn't be part of this grand infrastructure to support research. That wouldn't be good, not from a long-term European societal point of view, as we're seeing the consequences of in daily reality at the moment.
Well, just to ask, I know that this is a toast, but science is global, so it doesn't make sense, to have a subset of everything that is needed. Reproducibility often depends on assets, resources that are not necessarily European, so we should look beyond. Then, of course, when it's time of monitoring, assessing, of course, we'll confine the investigations to European resources, so we can compare how we're going with respect to the global frame. On the other hand, you need to depict and to have the whole picture if you want to be able to make such comparisons and enable such ecosystem.
Thank you. Anything else? In that case, I hope you go away with a better understanding of what the 07 and horizontal services are. I'd like once again to thank all of our speakers. Thank you.